Today's lesson is on determining if a relationship is proportional. To determine something is to make a decision about it. When it talks about a relationship in math, they're not dating, it's just how these terms relate to each other, what their patterns are. And proportional is just referring to a multiplicative relationship. So if we're determining if a relationship is proportional, we're trying to decide if there's a multiplicative relationship between two terms. For this set of video notes, this is just a lot of yes or no. It's not really something we're going to have example 1, example 2, example 3 for. So for the purposes of this video, you're writing everything down as if it's vocabulary, and we're going to give an example and a non-example for each of these. So this slide you're going to copy. If you want to go ahead and pause and copy this down and then fill in a table to the right and a graph to the right, we can do that together in just a sec. So for example, looking at this table, we're trying to figure out if the relationship of y divided by x, because that's what that slash sign means, is y divided by x, y over x, is consistent. Is there a multiplicative relationship? And you might be wondering, why are we going to divide to see if there is? Well, if I take y and divide it by x, that's 8 divided by 4, which is 2. For my second row, I divide y by x, that's 20 divided by 10, which is also 2. And then for my third row, I divide 6 by 3, which also is 2. This means that for each one of these, I am multiplying by 2 to get from x to y. So yes, there is a multiplicative relationship because my y divided by x is constant all the way down my table. Now here's an example that I don't want you to copy. I'm going to draw it in blue over here. If you start to solve it and decide, yes, I need this in my notes, you're welcome to write it down. But I don't think that it's necessary. I think having the example, not necessarily a non-example, is what's most useful. So let's look at this one. If I see this table that says 5, 6, 7 for each of the x's, and 8, 9, 10 for each of the y's, we can see that there is some kind of relationship between these variables. But it's an additive relationship, meaning for each one of these, I add 3 to get from x to y. But when I check for my constant of proportionality, my y divided by x, I get 8/5, 9/6, which simplifies to 3/2, and then 10/7, which can't simplify. These aren't constant all the way down, which is why this one is not a proportional relationship, but our first one was. Now let's check out our proportional relationships in graphs. Now in my graph, I have the y-axis and I have my x-axis. And when I draw the graph, if it starts at 0, 0 and keeps a linear rate, which means it forms a straight line, then it is proportional. Again, I'm going to show you in blue an example of a not proportional relationship so that you can see what that looks like, but the not proportional relationship you don't have to put in your notes. So if my graph doesn't start at 0, 0, but starts somewhere up here on the y-axis, it's already not proportional. You also might see a graph that increases proportionally, but then becomes more stagnant and then increases again. There's a break in this graph. There's no longer a constant proportional relationship like there was in our first one, so this one is not proportional. We're going to follow the same method for copying notes on this page as we did the last. You're going to copy what makes an equation proportional and what makes a description proportional, and then you're also going to copy the example that I give you, and then we'll also go over a non-example that doesn't need to get copied. So if you want to fill in like an outline right now for us to fill in with an equation and a description, now is your chance. All right, ready to get started? Let's say that my equation is 8 x. This represents a proportional relationship because between the y and the x, I have something that's being multiplied. I have that 8 being multiplied, so that's proportional. Now, funnily enough, if I have x over 8, that's still actually a proportional relationship because you also could write it as an 1/8 of x. And I know what you're thinking. Well, if the division works as well, because, inverse of multiplication, what isn't a proportional relationship in an equation? Well, let's do that in blue over to the side. If I had 8x plus 1, that is no longer a proportional relationship because it's not just multiplicative. You're also adding that 1 to the back. Or if I have y equals x minus 4, it's no longer a multiplicative relationship because you're going to be subtracting some number to the side. What I'm looking for in a multiplicative relationship is I'm looking for just the y and the x and then one thing that's being multiplied by it. All right, let's move on to a description. How about this one? I gained 5 pounds each week of quarantine. Is there a multiplicative relationship there? Honestly, for this, it kind of depends on what your x and y variables are going to be. So if y is the total that I've gained, and x is how many weeks there are, then yes, this is a multiplicative relationship because I would multiply a 5 by the number of weeks. There's a constant increase. One way you could think about it where it's not proportional is if you have y being my total weight, and then I have 5 multiplied by x, which is the number of weeks. This actually wouldn't be multiplicative because it would be 5x plus whatever my weight was when I started off. So no longer multiplicative, but as long as you're looking at total gained multiplied by the number of weeks, gaining 5 pounds each week of quarantine is a multiplicative relationship. Now it's time for you to try 2 problems. You don't have to copy these into your notebook, but you need to try them and then play to check your answer. Is the table for number 1 proportional? And is the description for number 2 proportional? Yes or no? Let's get started. For number 1, we're looking at the relationship between y divided by x. So I say y divided by x, y divided by x, y divided by x. Now you can leave these as fractions, 8 over 7, 10 over 9, 12 over 11, and already see that those are not equivalent fractions, so no, there's not a constant relationship. You also have the option to divide them out, and you can see that this is not a constant relationship. So again, not proportional. For number 2, Ms. Schaefer grades 5 quizzes in 10 minutes. Is there a proportional relationship there? Well, is there a way that I could multiply by 1 to get to the other, and is it always going to work? So I like to make a table whenever I'm not quite sure. So we'll do the number of quizzes and then the number of minutes that it takes. So if it takes me 5 quizzes in 10 minutes, then every 1 quiz takes me 2 minutes. So 100 quizzes would take me 200 minutes. Yes, this is a proportional relationship because I can find a unit rate for this, and it continues to show the same ratio of increase. It's always multiplied by 2. No matter how many quizzes and minutes that we're talking about.